Atomic structure, specific charge, particles and radiation, Unit 1. Specific charge is the ratio of charge to mass. A charge Q divided by mass m. The unit for charge is coulomb and unit for mass is kilogram. So that's coulomb per kilogram. Question A, calculate specific charge of proton. We know the mass of proton and the charge of proton. So for proton, the charge Q is plus 1.6 times 10 to the power minus 19 coulomb. And the mass of proton is 1.673 times 10 to the power minus 27 kilogram. The specific charge will be plus 1.6 times 10 to the power minus 19 coulomb divided by 1.673 times 10 to the power minus 27 kilograms. And that will give, make sure calculator is on, use the fraction key, 1.6 times 10 to the power minus 19, arrow key down, 1.673 times 10 to the power minus 27 kilogram. So that's 9.56 times 10 to the power 7 plus 9.56 times 10 to the power minus times 10 to the power 7 coulomb per kilogram. So that's the specific charge for proton. For electron, Q for electron is minus 1.6 times 10 to the power minus 19 coulomb. The mass for electron is 9.11 times 10 to the power minus 31 kilogram. And that implies specific charge will be equal to minus 1.6 times 10 to the power minus 19 over the mass of electron is 9.11 times 10 to the power minus 31 kilogram. And when we plug that into calculator, again use a fraction key, 1.6 times 10 to the power minus 19, 9.11 times 10 to the power minus 31. So that will be 1.76 times 10 to the power 11. That's minus 1.76 times 10 to the power minus 10 times 10 to the power 11 coulomb per kilogram. So that's 11. To calculate the specific charge for carbon-12 nucleus, okay, this is referring to the nucleus now. In the nucleus, we got 6 protons. The neutrons don't have any charge, but they have a mass. So for the charge in the nucleus, that would be 6 times 1.6 times 10 to the power minus 19 coulomb. And for the mass, for proton would be 6 times 1.673 times 10 to the power minus 27. And for the neutrons, it would be 6 times 1.675 times 10 to the power minus 27 kilograms. So we could plug that in to calculate the specific charge, which is charge over mass. Again, so we can plug that into calculator and see what we get. So with the calculator, use the fraction key. I will use open bracket 6 times 1.6 times 10 to the power minus 19. So that'll be the charge. So I'm going to use open bracket. And for the proton, that'll be 6 times 1.673 times 10 to the power minus 27, close bracket, to open bracket 6 times 1.675 times 10 to the power minus 27, close bracket. After closing the bracket altogether, so we get 4.78, so that will be 4.78 times 10 to the power 7 coulombs per kilogram. 47.78 times 10 to the power 6. So I'm just using the scientific notation. So that would be 4.78 times 10 to the power 7 coulombs per kilogram. So that will be a plus. Question C. Calculate the specific charge for carbon 12 with 8 electrons. So carbon 12 has in 8 electrons. It's implying that it's got 6 protons, 6 neutrons, 8 electrons. That's why it's got ions. So in this case, we got the protons, 6 protons there. So that's 6 times 1.6 times 10 to the power minus 19 coulombs. That's the charge. So that's positive. And then we need to add that to the charge of electron, which is 8 times minus 1.6 times 10 to the power minus 19 coulombs, because that's charge of electron. There are 8 of them. There are 6 of protons, because it's carbon 12. So carbon 12 will be 12 and 6. And because it's got 8 electrons, 6 protons, the charge will be 2 minus. And you can see that and that will cancel each other out. And then really, because the charges is the same, all we need to do is multiply. Instead of doing that calculations, we don't need to do that calculation. We can just do 2 of the electrons, because that's what we got, 2 minus. The overall charge is 2 minus. So the charge that we need, Q, should be 2 times 1.6 times 10 to the power minus 19 coulombs. So obviously it's negative. So that charge will be negative. And that's all we need. And then we need to then divide it by the mass. And the mass in this case will be the mass of the whole thing, because we got the mass of the mass of electrons are specifically really low, so it doesn't have that much effect, but we can put it in. So we've got 6 protons, 6 neutrons, so that would be 6 times 1.673 times 10 to the power minus 27 plus 6 times 1.675 times 10 to the power minus 27. Or you could do a rough estimate of 12 times 1.673 times 10 to the power minus 27, because this is really very close together. And the mass of electrons, because if you involve the electrons there, so that would be plus. The electrons are 8 electrons, so that would be 8 times 9.11 times 10 to the power minus 31. Because it's so small, it would really have no effect on it. So with the calculator, instead of doing all that for the charge, we're just going to be, because that will offset this one. 6 of these will offset 6 of those. So the difference is just 2 of these. So that's what we go there. Right, open the fraction key. And so you got 2 times 1.6 times 10 to the power minus 19. Arrow key down. Now this time, open bracket. I got 6 times 1.673 times 10 to the power minus 27. That's for the protons, close bracket. And I need to add that to plus to the neutrons. That would be open bracket, 6 times 1.675 times 10 to the power minus 27, close bracket. And I need to add that to the electrons, open bracket. And that's 8, because it's got 8 electrons, isn't it? Times 9.11 times 10 to the power minus 31, close bracket. So overall, I'm getting 1.59 times 10 to the power 6. So that will be 1.59 times 10 to the power 7 coulomb per kilogram. So We need to put minus in there because remember it's a negative here, so that would be negative. Or you can say negative 1.6 times 10 to the power 7 coulomb to 3 significant figures. So that would be minus 1.60 times 10 to the power 7 coulombs per kilogram. So that's a specific charge for carbon 12 with 8 electrons. We need to calculate the beryllium 9, 4 and nucleus. So again, this is talking about nucleus. So we're just looking for the nucleus here. In the nucleus, we've got 4 protons. So that'd be 4 times 1.60 times 10 to the power minus 19 coulombs. So that's for 4 protons. And we also have, and that's the only charge we've got there. Then we've got the mass. We've got, with the mass, we've got 5 neutrons and 4 protons. So that would be 5 times 1.675 times 10 to the power minus 27 plus 4 times 1.673 times 10 to the power minus 27. So this is for protons and that's for neutrons. And we add them together, so we divide that by the sum of that. Best is to use the fraction key, and you want the charge on top, so open bracket. You don't need open bracket, but 4 times 1.6 times 10 to the power minus 19, close bracket, arrow key down, open bracket. You want to do the mass now. 5 times 1.675 times 10 to the power minus 27. I'm going to add that to the proton, which is open bracket for that. And then I do 4 times 1.673 times 10 to the power minus 27, close bracket. And that's for the proton now. Altogether, we should get 4.25 times 10 to the power 7. So for that one, the specific charge is 4.25 times 10 to the power 7 coulombs per kilogram. Again, it's going to be plus because we're using plus. This is plus 1.6, so that'll be plus. So that's the answer to that one. So let me just put that's the answer to that. This is the answer to that one there. That's in 3 significant figures. And this is the answer to this one here. And that one there. We need to calculate the lithium. Lithium is plus. So obviously you can see, like we saw here, the overall is 2 minus. That's why we use 2 times the electrons. But here we got plus now. The overall is plus, right? So we're just going to use you got 2 electrons and you got 3 protons. You still got 1 positive more than the electrons. So that's what you use. Because the 2 electrons will cancel out the 2 protons. You only got 1 proton that's affecting the whole thing. So the charge in this case for this one will be 1 times 1 point plus, if you like, 1.6 times 10 to the power minus 19 coulombs. So that's the charge that is affecting because, it's, as I said, the 2 protons here will cancel out the 2 electrons. And the mass in this case will be, well, all 3 of them. So you've got the 4 times 1.675 times 10 to the power minus 27 plus 3 times 1.673 times 10 to the power minus 27 that's for the neutrons, by the way, and this is for the proton, plus 2 times 9.11 times 10 to the power minus 31. You can see it wouldn't have any effect because it's so small. Okay, so that would be the mass that we're going to be applying. And therefore, specific charge is Q over mass. That's charge. Q is the symbol for charge. So with the calculator, using the fraction key, the charge on top, so it's plus. So that will be, I'll just do 1.6 times 10 to the power minus 19. And then bring the arrow key down. Okay, I've got 3 of them to do. So I need 3 brackets. So the first bracket, open bracket, will be 4 times 1.675 times 10 to the power minus 27, close bracket. That's for the neutrons. And for the protons, so plus another open bracket, 3 times 1.673 times 10 to the power minus 27, close bracket. And then plus, again, I have to open a new bracket there for the electrons. So that would be 2 times 9.11 times 10 to the power minus 31, close bracket, for the electrons. And that would be equal to 1.37 times 10 to the power 7. So that would be 1 point. So that's a plus, because that's a plus there. 1.37 times 10 to the power 7 coulombs per kilogram.